Math is great, math is okay. You will need in life every day. From pandas to functions, to formula.
Alright, what I notice here is it tells me factor completely, and I have the first one, it's a trinomial. So trinomials, traditionally, you're trying to get into these binomials. Okay? Well, how do you know if you can factor it? Well, you take the highest degree, which is what, class? What's half of 3? This has to be 1.5. Is this 1.5, class? So the answer for the first one is not factorable or prime. Think about it. If the problem says something like this, let's just say you put into your binomials, you're guessing, and you put something like x squared times x. Yes? Well, x squared times x is how much? X to the third. That's getting what you want. But let's just say I put in some random numbers here, just to prove a point. And then you're multiplying by using FOIL. Then you'll get the outside terms as x squared, and then you'll get something like negative 2x minus 2. Do you see that? Do you see how you're kind of skipping a term? And that's the reason why this problem is not factorable. It's prime. So let's do factor each polynomial function over the set of real numbers. I have x cubed minus 8, and we talked about these 4 steps. So the first one is a cube root, meaning if I take a cube root of each of these, that should be a 3. What does that mean? You're looking for 3 identical numbers that multiply to be x cubed. The answer is x. And then it says 3 identical numbers that multiply to be 8. The number is what? 2. So basically this is my a value and this is my b value. So we just did step number 1. The second step is to use, write down the formula. Now, I gave you guys an acronym. What's the acronym, class? SOAP. So I'm going to start with A, and then the S stands for what? Same. So what am I going to put there? Minus B. A squared, then there's the S. Then what's the next letter? O, opposite. So the opposite of negative is a positive. So I have AB. And then the last one is AP, always positive. So plus B squared. Okay, so now I'm going to do the substitution. That basically says for every A value, we're going to put in X. And every B value, I'm going to put in 2. Now, in this problem, we're going to have a lot of parentheses, so I'm going to use a bracket for these. My A value is X minus 2. My A value here is X, and then the power of 2. My A value is X. My B value is 2. And then my B value is 2 squared. I don't need the parentheses here. I don't really need the brackets. So really all you have there is X minus 2. X to the power of 2 is just X squared. X times 2 is just 2X. Right now I'm just simplifying here. And then 2 squared is 4. So you have to use that formula to get this one, which is called a difference of cubes problem. And a special note, that last trinomial there, it'll never be, it never factors again. Never factors again. You can't use your X box. Alright, if I look at this problem here, I realize I have something to the 4th power, and half of 4 is 2, and that's not 2, so I should be thinking to myself about a greatest common factor. And when I take a greatest common factor,
Negative x squared.
I'm going to do a negative x squared. Raise your hand if you got that. Let me show you why you should have done a negative x squared. If I take a negative x squared, I'm left with what? 2x squared plus x minus 3. The reason why I had to take a negative is because when you're factoring a trinomial, you never want your leading coefficient to be negative.
That's right.
Okay, it's hard to factor like that. Previously in your lessons that if you have an a value that's greater than 2, you have to do both the x and the box. I'll show you really quickly. So you take inside the parentheses, highlight this for you. You're focusing right there. A times c is what? B value is 1. 2 numbers that multiply?
3 and negative 2.
3 and negative 2 is correct. Those multiply to be negative 6, add to be 1. Those two values here, we're going to put in your bottom left and your top right. And then inside your top left, you're going to put your leading coefficient, 2x squared. And then over here, you're going to put your last term. Class, what's the GCF of this row?
That would be 2x.
2x. This direction?
X.
And you can multiply to make sure that it equals that box. What's the GCF here? Negative 1. And negative 1 times 2x is negative 2x.
Oh, yeah.
What's the GCF here?
3.
And you can double check 3 times x, 3x. 3 times negative 1 is negative 3. So now I'm going to put in here x minus 1, 2x plus 3. Class, can I interchange those?
Yeah, you can.
Yeah, you can because it doesn't matter which order they're in multiplication.
Right.
Raise your hand if you got that. So when you factor it, this is my answer. So a lot of you probably found the GCF, but make sure that inside you keep factoring, you keep going. How do you know? Well, if you can't factor, it's prime, but if you think it's prime and it's not, then you're wrong.
These are fun.
Question number 2 says factor completely. You have a trinomial, 1, 2, 3 terms, so you can use your x box method. Your a value is equal to 1, so you only have to use the x. Remember, half of 4 is 2, so you can use the x box method. My a value is 1, b is 1, c is negative 20. A times c is negative 20. My b value is 1. Remember, list out all the combinations. So 5 times 4 will give me 20, but add them together equals 1. One of these has to be negative, so positive 5, negative 4. This will equal 1. But if I multiply that, it equals negative 20. So this is my answer. Negative 4, positive 5. And then this one you can add a 0x. And then do it again. And then it'll be 2 and negative 2. So this would be your answer. This one is partially correct, but you can keep factoring because it says factor completely.
Take a look at this problem now. I have 4 terms. And in my 4 terms there, I'm going to do something called factoring by grouping. Factor by grouping. It's a method. This is not what I traditionally teach in my class, like Xbox or different squares. So look at the problem here. I'm going to notice over here that they has a greatest common factor. The greatest common factor is a 9, a positive 9. I'm left with x minus 2. I want to pay attention to both of these terms because I'm hoping over here when I factor this side, one of them will be one of these. If I take out my greatest common factor, what do I get, class? X squared times x minus 2. Okay? If I'm paying attention, I realize that on both sides of the plus sign, they both have an x minus 2. So what I'm doing here is a second greatest common factor. I found a greatest common factor on the left side. I took a greatest common factor on the right side and on the left side, and then when I look at it, I realize they both have another x minus 2 in common. So I have x minus 2, and then I'm going to write everything I did not highlight. So I have x squared plus 9. And this would be your answer. Orange. So this is a method called factoring by grouping. And you can actually double check your answer. Let me show you guys how to do that. This whole quantity times x squared is the quantity times x squared. This quantity, the whole thing, times x plus 9 is this term up here. So you're kind of recognizing, and if you did FOIL, you would actually get this above. Okay, but this is a method called factoring by grouping. All right, last example here. 5 minus xy minus 3 times y minus x. In the previous problem, I recognized they both have an x minus 2 as my greatest common factor. Down here, they're not exactly the same. Let's just say you switch this. Let's just say you have something like negative 3 times negative x plus y. That's okay to do, right? Because the math operations are still the same. You see that? This negative 3 I'm going to pull out here. And in the parentheses, I'm going to factor out a negative 1. So ignore the negative 3. Negative 1 times something equals negative x. That'll be x. Negative 1 times something equals a positive y. What is that, class? Negative y. So I factor out a negative 1, and you can always distribute to check your answer. Okay, so when I put it back into the problem, 5 times quantity x minus y. I'm going to put all of that right here. This is negative 3 times a negative 1 times x minus y. I'm just going to go through and simplify now. I have 5 times x minus y. Class, what's negative 3 times negative 1? Positive 3. And I have this xy. Normally, students are tempted to distribute here. But look at what the directions say. The directions say factor completely, not expand. Expanding would be back in standard form. Does that make sense? We're just trying to condense it as much as possible. So here, this is as similar as something like 5m plus 3m. Do you see that? These are like terms. You can add those, you just add the coefficients and you get 8m. So here, I can combine like terms. I'm going to get 8 times the quantity x minus y. And this would be my answer. So here there are 4 examples of different types of factoring.
Missing formulas in life? Problems becoming too difficult to clear? Well then, you need Mr. Math Cleaning Solution. Just spray the liquid formula onto the mess, then wipe it clear, and enjoy the result. Mr. Math. Stay clean and calculated. Order now at www.gpproduction.com and get an additional